Hi, welcome to my video on solving word problems using the natural logarithm ln, part 3. An investment bond worth $1,000 increased to $8,500 in 6 years. In how many years will it be $18,000 from the initial time when we started? So we have A equals AO e to the RT, or could have K. And notice that R is an increase, so the rate is positive. So we have growing from 1,000 to 8,500. So that's the initial. AO is 1,000 going to 8,500 E, and we don't know what R is, but it's happened in 6 years. So divide 1,000 into 8,500 is 8.5 equals E to the 6R. And we'll do the ln of each side. And the reason to do ln is that we'll get the R to come down in front by the power rule. So 6R is ln E. And the ln of E is 1, so 6R times 1 is 6R, ln 8.5. So R is the ln of 8.5 divided by 6. So you take your calculator, do the ln of 8.5 divided by 6, and you get 0.3567. Now, that could also be changed to a percent, which is 35.65%. That's a good investment bond to have because the rates today are not the same. So we could either go 35.7% or we leave it like that. Now we want to find how many years growing at this rate to take it to get to 1,800. So A equals AO E RT, and it's $1,000 going to $18,000, and the rate is 0.3567, and times t. We're looking for the time. 1,000 and 18,000 is 18. E 0.3567 t, and we'll do the ln of each side. And by the power rule, the 0.3567 t moves in front of the ln E. The ln of E is 1, so 0.3567 t equals ln 18. And ln 18 divided by 0.3567. When we divide, we get t, and so t comes out to be 8.1 years, or close to a little more than 8 years. So the time is 8.1. Okay, let's do another one. If the population of a city doubles every 14 years, find its tripling time. And we have the equation AO E RT, or we could have a K, and we're doubling, so R is going to be positive again. So doubling means that A equals 2AO, doubling. So we're doubling, so it's A is 2AO, AOE R, and time is 14 years. So the AO's cancel out, so 2 is equal to E 14R. Do ln of each side. And we have ln 2 equals the 14R moves in front because of the power rule on the ln. And the ln of E is 1, so we get 14R equals ln 2. So ln 2 divided by 14 equals, we got equal sign, R. So R it comes out to be 0.0. Use your calculator. Ln of 2 divided by 14, 0.495. Again, we could make it 4.95%, but we could leave R there because now we got to find the tripling time. So A, AO, E, R, T, and we got to find the tripling sign. So this time A is going to be 3 times. Notice we got 3 times AO. So whatever value you have here, you double it. So if that was 5,000, this would be a 10. This is 4,000, this would have been 8. So but when you divide 4,000 into 8,000, you still get the 2. So tripling time works the same. You don't. So it's A is 3AO, E, and the rate is 0.0495T. We're looking for the number of years to the nearest year, so we divide by AO. So 3 equals E 0.0495T. Again, we do the ln of each side. We could do the log, LOG, but ln comes out to be quicker. 0.5 power moves in front of the ln E. The ln of E is 1, so we get 0.0495T equals ln 3. And we take the ln of 3 and we divide it by 0.0495. Because that's a multiplication, we divide on the other side, so T comes out to be 22.194 when you use your calculator. And so that means the answer to the nearest year is 22. Again, using the ln, natural logarithm, because we have an E, and remember the ln of E is 1. And one more problem. A substance decayed from 80 grams to 60 grams after 90 days. How much to the nearest unit remains after 200 days? And again, we have a quantity, amount. So A is AO, E, and we could use an R, a rate. We could use a K. I'm just going to use a K this time instead of an R. And notice that this time it's going down, so the K is going to end up to be negative when we find it. So it decays. The initial is 80. It's decaying to 60. And E, and the time is 90 days, so it's K times 90. Remember, K is the rate of decay. Same thing. I'm using K now only because some books use K, some teachers. Divide by 80. Cancels. So E to the 90K. And 60 that's a 3/4, which is decimal 75. And again, I'm going to use the ln. I'll find the ln quicker instead of log. And power rule, the 9K moves in front of the ln E. The ln E is 1, so 9K equals the ln of 0.75. So K is equal to the ln of 0.75 divided by 9. Use your calculator, and that comes out to be a negative 0.003. And again, it's negative because we're getting a decrease here, so that's why K is negative. Now we want to find how much remains after 200 days. So A, AO, E, K, T, and we want to find how much remains after 200 days. So we started off at 80, so we got to find what A is. E, K is 0.003, and T is 200. So that's 80. If you want to multiply those two out, you get 0.6. Just makes it easier when you plug it in the calculator. So when you plug it in the calculator, 80 and E to the decimal, oh, that's a negative there, and that's a negative. I almost made an error. That's a negative. So 200 times decimal 003 is decimal 6, negative. Plug this in a calculator and you get 43.9. And it says to the nearest unit, that's the nearest day. So the answer is 44 days. Again, similar to the other problem where we had to get the rate first and then use the rate and the time to come up with the amount after the 200 days. So, some extra, that's 3 videos I did on extra word problems to help you use the math that you learned. And if you like my video, click on the like button, click on the subscribe button if you wish to be a subscriber to my channel. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Hope the video was of some help to you. Bye-bye.